Everything you know is a lie.
Okay, this is an atom of helium because, is a funny element. Here you can see some negatively charged electrons just hanging out, and these little guys in the middle are positive protons and neutral neutrons. These three types of particles make up all atoms, and atoms make up all matter. So they really, really matter.
Now, you'd think these would be the smallest particles out there because they make up atoms, which make up everything. I mean, if you think about it, atomic physicists are actually just a bunch of atoms studying themselves. Anyway, there are actually even smaller particles that make up protons and neutrons, meaning protons and neutrons aren't fundamental. And it's quite surprising the nucleus is able to stay together, since the positive charges should repel each other. But that doesn't happen. So what's happening here? Well, as I said earlier, protons and neutrons aren't fundamental. They are made up of even smaller particles called quarks. The world is made up of quarks and leptons. So what holds it together? Well, the universe exists because these fundamental particles interact. There are 4 fundamental interactions: strong, weak, electromagnetic, and gravity.
And it's quite surprising that the nucleus is actually able to stay together, because the charges of the positive protons should repel each other. But that doesn't happen. So what is happening here? Well, as I said earlier, protons and neutrons aren't fundamental. They are made up of even smaller particles. These smaller particles are called quarks. As far as we know, quarks are not made up of anything else. Therefore, they're fundamental.
Now, the difference between a quark and a lepton is the interactions that act on them. Quarks interact with a strong force, whereas leptons do not.
Weak interactions are responsible for the decay of massive quarks and leptons to form smaller quarks and leptons. The strong interaction holds quarks together to form particles called hadrons. This interaction is what keeps the nucleus together. The electromagnetic force causes like charges to repel and opposites to attract. And the final interaction, gravity, is actually really weird, as it is clearly a fundamental interaction, yet the model cannot explain it. Additionally, leptons have a full charge, like +1 and -1. On the other hand, quarks only have a fractional charge, like +1/3 or -2/3. This is also why an electron is in fact a lepton. Both quarks and leptons have 6 different particles. There are 6 quarks, which physicists refer to in pairs. And don't get scared yet, the names are super easy to remember. Up, down, top, bottom, and charm, strain. On the other hand, we have the particles for leptons. These are electron, electron neutrino, muon, muon neutrino, and tau, tau neutrino. And we can't forget about bond, James.